friends, today we are going to start our fourth chapter of science of class 8, which is materials, metals and non-metals by Ashutosh. So let us start our chapter. And here are some topics that we are going to study in this chapter, which are what are materials, what are metals, what are non-metals, physical properties of metals and physical properties of non-metals and chemical properties of metals, and next point is chemical properties of non-metals, uses of metals and non-metals, and the last point is displacement reactions. So first of all, we're going to study about what are materials. So what are materials? The things or objects that are used by us are materials. Example is iron. Here you can see the photo of iron, aluminium and copper. So these are some of the examples of the materials that we use in our daily life. What are metals? So I want to tell you that the material which are hard, lustrous, malleable, ductile, sonorous and are good conductors of heat and electricity, these materials are called as metals, and this definition is also written in your book. Examples of metal are iron, copper, aluminium, calcium, magnesium, etc. So now we are on the examples of metals. Here are some of the examples of the metals: iron, copper, aluminium, magnesium and sodium. These are some of the examples of the metals. Now we are on that what are non-metals. So the material which are dull and soft in appearance and which can break down into a powdery mass on tapping with a hammer, they are not sonorous and are poor conductors of heat and electricity. These materials are called as non-metals. And some of the examples of non-metals are coal, sulfur, carbon, oxygen, phosphorus, etc. This is about the non-metal. Now we come on the examples of the non-metal. Here you can see there is oxygen, sulfur, and here it is that coal. These are the four examples of the non-metals. So physical properties of metals. Mainly there are. I want to tell you that mainly there are six physical properties of metals. These are hard, and metals are lustrous, and these metals are malleable, ductile, sonorous, and these are good conductors of heat and electricity. So the meaning of lustrous is the shining surface. The meaning of lustrous is the shining surface, and malleable is that it can be beaten into thin sheets, and ductile is that it can be also beaten round and can be used to make wires. And sonorous means they can when we hit them they will make a voice, and these are also the good conductor of heat and electricity. And now we come on the physical properties of non-metals. These are dull in appearance, these are not hard, means these are soft, and these are not malleable, means non-metals are not malleable and not ductile and not sonorous. They are also not good conductors of heat and electricity, means not all but some of them are not good conductors of heat and electricity. Chemical properties of metals: reaction with oxygen, reaction with water, reaction with acids, reaction with bases. These all we will study in this topic, chemical properties of metals. So first of all, reaction with oxygen of metals. So I would tell you that you are familiar with the phenomenon of rusting of iron. Recall the reaction by which rust is formed. An activity of burning of magnesium ribbon in air. You have learned that in both the processes oxide formation take place. Means you must be familiar to the phenomena which is rusting of iron. Means You have seen the brown color like thing on the iron which eats it up. Many people say that the rust eats up the iron. Yeah, they are right. It's just a reaction. And an activity of burning magnesium in air you have also learned that in the both processes oxide formation take places. Means in rusting of iron and burning of magnesium ribbon, both the process take formation of oxide. So latest I mean to say that this is the latest activity. So let us do the activity to check the nature of the rust form as a result of the reaction between iron, oxygen and water. Collect a spoonful of rust and dissolve it in a very little amount of water. You'll find that the rust remains suspended in water. I'm sorry that the spelling of rust is written R-E-S-T. You can write it as R-U-S-T. Rust remains suspended in water and shake the suspension well. Take the solution with red and blue litmus papers. So we have done activity which is between the reaction of iron, oxygen and water. You can take a spoonful of rust, means from anywhere near old iron, and dissolve it in a very little amount of water, and then you will find that the rust remains suspended in water. Shake the suspension well and then test the solution with red and litmus paper. Red and litmus papers, in last class I told you that red and blue litmus papers are used to check that that the solution is acidic or basic. So now we call the activity of that burning magnesium ribbon to the ash obtained on burning magnesium ribbon. So now ribbon is dissolved in water and tested for it is acidic basic nature. Now when the burning magnesium ash is obtained after the burning of the magnesium ribbon, then it is dissolved in water and it is also tested that with the blue and litmus paper and to know that this is acidic or basic in nature. So you must have observed that the red litmus paper turns blue. So oxide of magnesium is also basic in nature. In generally metallic oxides are basic in nature. So you must have seen that in the rust and in the ash of the burning magnesium ribbon, both are basic. So you must have observed that your red litmus paper turns into blue. So now we move to the next part. Now we come on the reaction with water. So let's see how metals react with water. Sodium metal is very reactive. It reacts vigorously with oxygen and water. A lot of heat is generated in the reaction. It is therefore stored in kerosene. So I want to tell you that sodium is a very high reactive metal, and it can react vigorously, means very fastly with oxygen and water, and a lot of heat is generated in the reaction in its reaction, and that's why it is stored in kerosene. So now let us perform activity to see how metals react with water. You can take 250 ml beaker or glass tumbler, fill half of it with water, and now carefully cut a small piece of sodium metal and then dry it using filter paper and wrap it in a small piece of cotton. Put the sodium piece wrapped in the cotton into the beaker. Here would be beaker, by mistake it was written bigger. So now observe carefully when reactions touch the beaker and test the solution with the red and blue litmus paper. And when the reaction stops, you must touch the beaker, and now you should also test the solution with red and blue litmus paper to check that the nature is acidic or basic. You must have observed that sodium reacts vigorously with water and some other metals do not do so. For example, iron reacts with water slowly, but sodium reacts with water very fastly. Means vigorously it is written over here. Reactions with acid. Now we come on the reactions with acid of metals. So let us see how metals behave with acids. Now let us perform an activity to see that how metals react with acids. Take samples of metals in separate test tubes and label them as A, B, C, D, E, F. And with the help of a dropper and 5 ml of dilute, here it is dilute hydrochloric acid. So here would be dilute, D-I-L-U-T-E, dilute hydrochloric acid to each test tube. To each of the test tube, you one by one observe the reactions carefully. If no reaction is occur in the cold solution, warm the test tube gently and bring a burning matchstick near the mouth of each of the test tube. So you can take samples of the metals in separating of the test tubes by separate test tubes, such as you can mark the test tubes as A, B, C, D, E and F. And with the help of a dropper, you can put 5 ml of dilute hydrochloric acid to each test tube, and you should one by one observe the reactions carefully. If no reaction occurs in the cold solution, means if it is a cold solution, then warm the test tube and then bring a burning matchstick near the mouth of each of the test tube and see what reactions takes place. And repeat the same activity using dilute sulfuric acid. Here also dilute is by mistake written in delete, so here it is dilute sulfuric acid instead of the dilute hydrochloric acid. You must have noticed that metals react with acids and produce hydrogen gas that burns with a pop sound. And you must have noticed that copper does not react with dilute hydrochloric acid even on heating, but it reacts sulfuric acid. So this is how the reaction takes place with acid. Now we come on the reactions with bases. So let us perform activity to know that how metals react with bases. So now prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 to 4 pellets of it in 5 ml of water and drop a piece of aluminium foil into it. Then bring a burning matchstick near the mouth of the test tube and then observe carefully. And you can prepare a fresh solution of that the sodium hydroxide in a test tube and dissolve 3 to 4 pellets of it in 5 ml of water and drop a piece of aluminium foil into it and bring a burning matchstick near the mouth of the test tube, and then you can observe carefully that what happens. You have seen indicated the pop sound. What does the pop sound indicate? I have a question. So the answer is, as before, the pop sound indicates the presence of the hydrogen gas. Yes. And metals react with sodium hydroxide to produce hydrogen gas. So now we come on the uses of metals and non-metals, and you should be able to guess that why metals are used in making machinery, automobiles, airplanes, trains, satellites, industrial gadgets, cooking utensils, water boilers, etc. And you are also familiar with the uses of some non-metals, and here are some interesting ones. We're sure that you will guess them right. Yes. So here are some of the uses of known metals and metals. So let us start. Now we come on the chemical properties of non-metals. Reaction with oxygen. Yes. And it takes also reaction with water, acids and base. So now let us first of all reaction with oxygen. Let us observe the reaction of non-metals with the oxygen. So let us perform activity for the observation. Take a small amount of powdered sulfur in a deflagrating spoon. As soon as the sulfur starts burning, introduce the spoon into gas jar, glass tumbler, cover the tumbler with a lid to ensure that gas produced does not escape. Remove the spoon after some time, add a small quantity of water also into the tumbler and quickly replace the lid. Shake the tumbler well and check the solution with the red and litmus papers. Then you will know that how it reacts with oxygen. So now we come on the reaction with water. Let us see how nonmetals behave with water or reacts with water. Sodium metal is very reactive. This is the same activity that I have told you in the reaction of water with metals. Sodium metal is very reactive. It reacts vigorously, and with oxygen and water, a lot of heat is generated in the reaction. It is therefore stored in kerosene. So now let us perform activity to see how nonmetals react with water. So take 250 ml beaker or glass tumbler and fill it half with water. Now carefully cut a small piece of sodium metal and dry it with a filtered paper, and then rapidly in a small piece of cotton put the sodium piece wrapped in cotton into the beaker. Observe carefully, and when reactions stop, touch the beaker and test the solution with red and blue litmus paper. You have observed that sodium reacts vigorously with water. Some other metals do not do so. For example, iron reacts with the water slowly, but non-metals do not react with water. This is the answer at last. So now let us see the reactions with acids of non-metals. Let us see how non-metals behave with acids. Now let us perform an activity to see how non-metals react with acids. Take samples of non-metals in separate test tubes and label them as A, B, C, D, E, F. And with the help of a dropper and 5 ml of dilute hydrochloric acid to each test tube, you one by one observe the reactions carefully. If no reaction occurs in the cold solution, warm the test tube gently and bring a burning matchstick near the mouth of each test tube. So it is the same activity that I have told you with the metals. This is the same with the with the non-metals, and repeat the same activity using dilute sulfuric acid instead of the dilute hydrochloric acid. You must have noticed that metals react with acids and produce hydrogen gas that burns with a pop sound, and you must have noticed that copper does not react with the dilute hydrochloric acid even on heating, but it reacts with sulfuric acid. And this is the answer, that non-metals do not react with acids. So now let us perform our activity to know that how metals react with non-metals react with bases. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 to 4 pellets of it in the 5 ml of water, and drop a piece of aluminium foil into it and bring a burning matchstick near the mouth of the test tube, and observe carefully that what does the pop sound indicate. As before, the pop sound indicates the presence of hydrogen gas, and metals react with the sodium hydroxide to produce hydrogen gas. This is the same activity that was in the metals. Uses of metals and non-metals. Sorry. So here are some of the uses of metals and non-metals. This have again came, so I will read for you again. You should be able to guess that why metals are used in making of machinery, automobiles, airplanes, trains, satellites, industrial gadgets, cooking utensils, water boilers, etc. You are also familiar with the uses of some non-metals. Here are some interesting ones. We are sure that you will guess them right. Now let us see. Non-metal is essential for our life, which all living beings inhale during breathing. This is oxygen, O2. Second is non-metals used in fertilizers to enhance the growth of plants. Yeah, it can be. Non-metals used in water purification process. Yes, it is. And non-metal used in purple colored solution which is applied on wounds as a antiseptic. Yes, it is also. And non-metals are used in crackers. It is also right answer. And this now it come on the main topic, displacement reactions. So now let us perform our activity to know that how our displacement reactions take place. So take 500 ml because take 500 ml of water because and label them A, B, C, D and E and take about 50 ml of water in each beaker. Dissolve it in each beaker, a teaspoonful of each of the substances. So keep the beakers and distribute for some time and distribute it for some time. Record your observation in a notebook. And what changes do you observe in the various beakers? You have read that one metal displaces another metal from its compound in aqueous solution. In beaker, a zinc replaces copper from copper sulfate. This is why the blue color of copper sulfate disappears and the powdery red mass of copper is deposited at the bottom of the beaker. And you can write down reaction taking place in beaker in a similar manner, and there could have been displacement of zinc by copper in beaker C and by the iron in beaker E. Similarly, iron can be displaced by copper in beaker D. Since we did not see that any change in beaker number C, we can infer that copper is not able to replace zinc because from zinc sulfate. But why? When zinc replaced copper in beaker A, why can't copper replace zinc in beaker C? So the answer is, remember that science is not arbitrary, it follows definite rules based on facts and the rule here is that zinc is more reactive than copper and iron. A more reactive metal can replace a less reactive metal, but less reactive metal you can understand, but a less reactive metal can't replace the other more reactive metal. So now we can understand that why there are no displacement reactions in beaker number D and E. So